Hello everyone. Today I'm going to be doing problem 4.51 for Mastering Physics homework for the first quarter of the Calculus-based physics series. So this problem is a tennis player hits a ball 2.0 meters above the ground. The ball leaves his racket with a speed of 15 meters per second at an angle of 5.2 degrees above the horizontal. The horizontal distance to the net is 7.0 meters and the net is 1.0 meters high. Does the ball clear the net, and by how much? So the answer to A is pretty self-explanatory because without it we wouldn't have an answer B. So we can kind of rule that one out and just go ahead and start with working on proving how much he's going to clear it by. So probably the most important thing in any physics problem is starting out with a picture. I hope you guys can see it, but this is essentially where the ball is being hit. This is the net. Here is the angle and the vector for the velocity of the ball, and the origin is down here where the height would be 0. So for the knowns, we know that the height initial is 2.0 meters, the height of the net is 1.0 meters, and velocity is 15 meters per second, and we know that the angle theta is 5.2 degrees. So for the equations we're going to be using, we have velocity naught in the x direction equals velocity naught times cosine theta. Velocity naught in the y direction equals velocity naught times sine theta. And x final equals x initial plus v naught t plus 1/2 at squared. So one of the first things you want to start out with is going ahead and making a chart to kind of get a process or a hold on what you're going to be doing and what you need to find. So we know in the x direction that the v naught is equal to this equation here. So v naught is 15 meters per second times cosine of theta, which will give us our x direction. So we can rewrite this theta as 5.2 degrees. So our v final is going to be the same because velocity in the x direction is always constant because gravity doesn't affect the velocity. So we can write 15 cosine of 5.2 degrees there. So like I said, the acceleration is going to be 0, so we can go ahead and just put a 0 there. The distance, we know we want it to travel 7 meters, 7.0 meters, and so we don't know the time yet, so we're going to find that first. So let's start with that. So let's use this equation for x final equals x naught plus v naught t. Now since we don't have acceleration, we can go ahead and get rid of that the last part. So our 7 equals 0 because it's starting at the 0 point plus 15 cosine of 5.2 times t. So that must mean that our t is equal to 7 over 15 cosine 5.2. And we can approximate that to be about 0.47 seconds. But for the sake of the problem, I'm going to leave it in this form just so we can be exact. So the next thing we're going to want to find is the velocity in the y direction. Well, specifically, we'll fill out this chart a little bit more. So we know that the velocity in the y direction is using this equation, v naught y equals v naught sine theta. So we're going to have 15 sine 5.2. Now we don't know v final yet because there's going to be acceleration due to gravity, which is negative 9.8 meters per second squared. Now the distance we don't know, that's what we're trying to find for the problem. And the time, we can put equal here because they're going to be the same point. This is about 0.47 seconds, or I'm going to put 7 for 15 cosine 5.2. Okay, so now we can go ahead and use this equation up here for the y direction. I'm going to do a little line here. Alright, for the y direction, I'm going to label it as y instead of x just so we can be clear. So y final equals y initial plus v naught t plus 1/2 at squared. Alright, so now we're going to put in our knowns. So we have y final equals, we will do 2 meters since it's starting back up here from the point where the ball is impacted, plus v naught, which we said was 15 sine 5.2 plus 1/2 acceleration due to gravity, which is negative 9.8, and then we have our t squared, which I'm just going to label t here, but it's equal to this down here. Okay, so we'll fill that in a second since I'm running out of room. So y final equals, let's just plug this into our calculators. So if you plug this whole equation in, including what we got from t, I'll put it down here so it's clear. So t equals 7 over 15 cosine 5.2. Okay, so if you plug all of this into your calculator, you're going to get 1.561100662 meters. I can go ahead and just round that up to 1.56 meters. So that's going to be the height of the ball at the time where it's crossing over the net. So now what we need to do is take this minus the height of the net. And for a final answer of 0.56 meters above the net. So once you finish a physics problem, you always want to think about, does it make sense? And I think that it's pretty clear that this one does make sense. Because if you just basically look at the initial velocity of 15 meters per second and a time of 0.47 seconds, it's pretty clear that it's going to travel the entire distance easily because of the velocity alone. So it's safe to say that it's going to clear the net, and 0.56 meters makes sense because of the angle, 5.2 degrees, is relatively shallow, so it's not going to clear it by a whole lot. So I hope this helps you guys figure out everything, and have a nice night.